Let's rationalize a denominator for these fractions that have more than one term added or subtracted together in the bottom of the fraction. Let's see, for part A we have 6 over 2 minus the square root of 7. Okay, what do we have to multiply the bottom by in order to get rid of the radical? Well, when you have more than one term in the denominator, you multiply by the conjugate of the bottom over itself. The conjugate of the bottom is 2 plus the square root of 7. See, it looks just like 2 minus the square root of 7 in the bottom of the first part, but the sign in the middle is different. Over itself, 2 plus the square root of 7. Now, on the bottom, well, on the top it's just 6 parentheses 2 plus the square root of 7, but on the bottom we're going to use a formula. We're going to use a plus b times the conjugate a minus b equals the first dude squared minus the last dude squared. So this is 2 minus square root of 7 times 2 plus the square root of 7. Using the formula, we get the first dude squared, 2 squared, minus the last dude squared, square root of 7 squared. And the square root of 7, when you square it, it's going to cancel the square root. So leave the top alone, and square 2, you get 4, square the square root of 7, and you get 7. So leave the top alone, and on the bottom 4 minus 7 is negative 3. We can cancel a factor of 3 on the top and the bottom, a negative 3, and we're left with negative 2 times parenthesis 2 plus the square root of 7. You don't need to distribute the multiplication, that's fine. Okay, next problem. Square root of 2 minus square root of 3 over square root of 2 plus square root of 3. Now, you know, it's weird because that is a conjugate over, it's 2 terms over its conjugate, but that's just to distract you. You shouldn't be noticing that. What you want to notice is that you have more than one term in the denominator, and at least one of them has a radical. So you're going to rationalize the denominator by multiplying by the, take the original question, the original fraction, put parentheses around the top, parentheses on the bottom, and multiply by the conjugate of the bottom over itself. So the bottom was the square root of 2 over plus the square root of 3. The conjugate would have a minus sign in the middle. So we're multiplying by the square root of 2 minus the square root of 3 over itself. And on the bottom, we're all set up to use the formula for the multiplication of conjugates. On the top, just write the parentheses, don't do any work yet. On the bottom, it's the first guy squared minus the last guy squared. And we cancel the radicals with the second power. The bottom becomes 2 minus 3. Let's see, on the top, we can FOIL. First times first is square root of 2 squared, plus the product of the outers, plus the product of the inners, plus the bottom, the last guy squared. Okay, so we simplify and we get 2 minus the square root of 6, 2 minus the square root of 6, minus the square root of 6, plus 3, all over negative 1. So that simplifies to 5 minus 2 of these square root of 6 over negative 1. Bring the negative 1 upstairs and distribute it. Negative 5 plus 2 square root of 6. And I'll put the positive term in the front, 2 square root of 6 minus 5. Whew. Finally, the square root of x over square root of x plus square root of y. Okay, so we have 2 terms on the bottom, and both of them are radicals. To rationalize the denominator, we're going to multiply by the conjugate of the bottom over itself. So this question is equal to itself times the conjugate of the bottom over itself. So it's the square root of x minus the square root of y over the square root of x minus the square root of y. They're both minus, that's the conjugate of the bottom, and they have to match. On the bottom, on the top, we'll distribute the multiplication across the parentheses in a minute. On the bottom, we apply the formula first guy squared minus second guy squared, and each of those radicals cancel on the bottom, x minus y on the bottom. Let's see, distributing the multiplication on the top, we get the square root of x squared, so we have a cancellation there, minus the square root of x times the square root of y. So we get the cancellation to get x, and then minus, and then we can do the multiplication for the square root of x times the square root of y under a common square root symbol of x times y over x minus y. And as many x's and y's that are floating around there, it's still impossible to cancel any common factors on the top and the bottom, because most of the things you're looking at are either under the radical and they can't cancel on the outside, or they're not even factors. Only factors can cancel. We've got terms that are added and subtracted together. They cannot cancel.